Tim, good to see you, buddy. How you doing? Assuming
Uh, I'm just fine, thanks. How are you?
doing great, doing great. It's a beautiful day here in Seattle. We've had clear blue skies. Looks like you have clear dark skies there in the Netherlands with the time difference. But what was the weather like before you could when you might have
The
gone
weather
outside?
was quite pleasing to look at. About 15 minutes ago, I had the brightest purple sunset I ever saw from here,
Oh,
out of
gorgeous.
11th floor up, so I can see the whole horizon of just I don't know a very
That's
dark
nice.
purple.
That's nice. Just a few blocks from me is a hill that overlooks the Puget Sound. So you've got ocean, and then snow-covered mountains on the other side, and then presumably more ocean on the other side of that. And that makes for a really gorgeous view. And I honestly don't get over there to look at it enough. So maybe I'll have to do that today for tonight's sunset.
It's recommended. Yeah, there's no hills whatsoever. If I want hills, I need to go to Germany, I think. But,
Yeah, I recall that from having visited the Netherlands a couple times. It's very flat. It seems like it might be in danger of sinking into the ocean a little bit. Do they have to do a lot of that of resisting sinking into the ocean in Amsterdam? I mean, you hear about it
it's
more in some other places, but
Yeah, so a large part of it is already below the sea level, but we just make do with dikes and pumps. It's going to be interesting looking ahead, like 50 to 100 years.
yeah,
I'm in the
lots,
east of the
lots of
Netherlands.
things get
I'm
interesting when you
yeah,
look at 50 to 100 years. Yeah.
yeah, definitely. Like interesting is the word, but yeah, we'll figure it out.
Excellent, excellent.
So yeah, no, glad that you all could join us. As always, we're going to take you through a few of the things new in the past week, and for that, I'm going to show a couple quick screens. And the first thing that we want to share is that we are now proudly part of the Pegasus startup program by Microsoft. So if you have wanted to use Modern, but you were tied by your organization's procurement processes, then all of that has now become a lot easier if you're already part of Azure and Microsoft stack there. So I'm really pleased with that. If you want to read the full details, there's a whole blog where we announce this to everyone. We'll share the links to our LinkedIn page as well here in the chat. And then, yeah, of course, from there, if you want to see what we could be doing for you here at Modern, then definitely reach out there. So pleased with that. Also new is that we finished that release that we were halfway through last week. So if you want to know what's new, then we now support those upgrades for the Cradle Kotlin DSL in a handful of recipes already, but the most well-used ones. So very pleased to have landed that.
Yeah,
And in turn,
regular listeners of our program will, of course, already have been apprised of that from our interview with Shannon, or at least we previewed that this would be available in that interview with Shannon, and now it's here. So give it a try if you have Kotlin Gradle scripts. We have a bunch of Kotlin Gradle scripts, so it's nice to finally have support for that. Be aware if you're trying to author recipes that operate on these, you're not going to have much type attribution to work with, but no, that was kind of already the case in the Groovy space. So if you're a Gradle recipe author, you're probably used to that.
absolutely. And if you want to dive deeper into that particular topic, then we have a blog post. But I think Sam, you wrote this one.
Yeah, well, Shannon and I wrote it together. Just a little peek under the hood of the history of like why it took so long for us to support this thing that we'd been talking about since 4 or 5 years ago when the company was founded. Like when we set out to support Gradle, like this was kind of always on the roadmap, and it just ended up being a little bit harder and more annoying than we expected. And so this is part explanation, part just story of how we got here. And yeah, so if you're curious about the implementation of these things, take a look.
Absolutely. And if you're curious where this might go, then we have another link that we could share, which is that the folks at Gradle are actually looking to leverage Open Rewrite for the upcoming releases that they do. This is, of course, a collaboration we're very much looking forward to, where we can together make sure that it'll get easier and easier to upgrade to newer versions of Gradle. So again, I'll share the link in the chat. Then there's a lot more that went into the release that we did last week. So there's a couple, I think 100 plus Neo recipes, mostly from folks at Oracle. on the WebLogic team to help you migrate to various newer versions of that. So we're really pleased with the collaboration that we have with folks there. And then beyond that, of course, there's our own recipes which are new. So there's a lot of new recipes to help you onto Spring Framework 6.2 or to help you onto Spring Batch 5.0. And all of that, of course, is going to be tied into the larger Spring composite recipes that we put out to help you upgrade to newer versions. There's also a bit of a theme going on with recipes aimed towards improving your test code. So if you want to move towards a cert J, then we cover even more cases these days. Or if you're still upgrading from JUnit 4 to 5, we also now support the timeout rule and another couple of use cases that we hadn't covered before and could definitely now service as well.
The timeout rule is one I feel nostalgic for. Before Open Rewrite existed, I worked on a very large code base that had honestly too many tests that were a little bit too much like end-to-end tests. So some of them just hanging for indefinite periods and making the test pass never complete until the whole CI job timed out was a real problem. And so I got some of my first taste of programmatic manipulation of not exactly code, but using the ASM bytecode manipulation library and a Gradle plugin I created myself to go and add JUnit 4 timeout rules to any class that didn't already have them, just to be like, no, these tests will take a finite amount of time, damn you. Now I wish that if I'd had something like Open Rewrite, I could have just put it in the text.
Yeah, it's a lot easier just to update the source, I imagine, than it is to hack that in with ASM.
It was a little bit harder to do a bytecode transformation than a code transformation.
Yeah. So for folks looking to now finally move away, there's options for you there. So then, looking further ahead, there's a couple new sessions coming up on conferences. Merlin will be
a little bit.
Sure. So this will be Merlin presenting at the JCon conference in Cologne in Germany, where he'll be giving a session on limiting your options. So we all know organizations that become larger and larger. Soon enough, they'll have every variety of logging frameworks, testing frameworks, and any kind of library that where you have a choice, you'll find all of them there. And we're going to look at how to comprehensively reduce that back down to something manageable, something standardized, the one true library that you want to go forward with. So we're looking forward to that one. Unfortunately, I'll have to watch the recording as I'll be in Miami at the same time for the Code Remix and the hack track that we're going to be doing there. So if you haven't booked your ticket yet, then definitely do so. We have a promo code, I think, still valid. If not, reach out and we'll find something that works for you, where you can join me and Sam and a handful of others to achieve the exact goal that you're after. Whether it's upgrading your tests or the Java versions or upgrading libraries or phasing out feature flags, moving away from outdated vendors, we're really going to be ready to help you out there at the hack track. So, any use cases that you're hoping to find some time for while we're there, Sam?
Oh man, I mean, it really just depends on what people bring to me. I once had an interesting experience interviewing for a software engineering position. It was supposed to be an interview with two software engineers who had, agreed in advance what question they were going to ask and evaluate me on. And one of them had to sub out at the last second for another person who had not gotten to do that coordination. So I, as the interviewer or interviewee, was put in the awkward position of kind of mediating between these two interviewers which question I was going to answer for them. And so I anticipate this might be a little bit like that, with people coming to me with a whole variety of recipe authoring or open rewrite questions that I cannot necessarily anticipate ahead of time. So I just hope that I will be able to help everyone.
It really should be interesting. And of course, we have the breadth of knowledge to be able to service a lot of these questions. And I think we'll see some corners arise, with corners like focused on testing, corners focused on maybe Java upgrades, or a lot of languages still. So really looking forward to this one. And then I think the week after, Andrzej is going to give a presentation in Krakow in Poland on the multi-language refactoring that we have with Open Rewrite. So This will be a fully new session. He's going to fly out and present to the folks there, just showing how we can actually, from the same core model, are able to support multiple languages. So, looking forward to seeing the recording there as well. Now, beyond that, we want to highlight some community work again this week, because we're just very pleased to have a community that helps out with just expanding the capabilities that we have. One thing I wanted to highlight this week is that support for generics in the refaster templating that we have. So there's a rewrite templating project, and now we are able to support generics there, such that we can convert more of the rules that our friends at Picnic have developed. And I've seen some numbers where we're able to convert all but 12 of the 900 rules that they have currently. Whereas
wow, so that like doubles the number of refaster template style rules that we have as recipes. That's pretty cool.
I really can't wait to see this in the platform and start to run these at scale. But we're finding some small issues still before we're able to really announce this. So as a backup, we have something that I also wanted to highlight this week, which is a new effort to support Java 24. Or community member called Francisco, I believe. Yeah, Federico Gonçalves is helping out bring Java 24 support to our Java parsers.
You love to see it.
Yeah. So there's some challenges there. I think we're close to getting this in. One of the limitations that we run into is that Gradle doesn't yet support Java 24. So that'll be an interesting mix for folks that look to migrate and use this. But we'll figure something out soonish, get this in, and from there be able to support migrations there as well. So really pleased with that level of engagement and folks taking on non-trivial tasks within the open source community, just to help the whole project further. And look forward to where this will go. So that's the things I wanted to show for this week. And then with that, I think we can move on to the main topic for this week. After that, we're going to bring on Isaac Van Doren. So, welcome, Isaac.
Hello.
Welcome, Isaac. Looking forward to your presentation at Code Remix Summit. I'm looking forward to this conversation. I'm also a fan of functional programming, and I've always kind of idly thought about, augmenting an existing programming language with new features. You're using Java or whatever in your day to day, and you're like, "Ooh, I wish there was this one little language feature." Often something from functional programming, a Haskell or what have you, that I wish I had access to in my current environment. So I'm very interested to talk to you, since you have been a contributor to the Roc functional programming language. Isn't that right?
Yep, that's right. Yeah, and I definitely resonate with you there. Wanting these features, and one cool thing about Roc is that it's designed to be very good at being embedded in other programming languages or other contexts. So if you have a Java code base and you say, this is a use case that I really want to use Roc for, you could always do that. Now you'll have to.
What is such a use case where you're in a Java code base and you embedding Roc makes a lot of sense?
Well, I think it would just depend on the. Well, I guess one place that there's a lot of potential coming up is as like a plugin language for, say, a game engine or something like that.
Yeah.
So one thing, Roc is designed. Well, okay, got to get the tagline is that it's a fast, friendly, functional language. Those are sort of the three core values there, and so it's very fast, and yet it's also very friendly in that it's easy to use and it's pleasant. It's like it evokes similar feelings to Python in terms of the way it looks and the simplicity, and yet you have all of this performance that you'd get from something like Go, for example, or Java.
So when we talk about speed in programming languages, there's a lot of different things that could mean. Two of the most common are implementing the language features with low overhead abstractions, something like C++ or Rust are like very serious about this. And then there's also like the speed of compilation and the developer tooling around it, which is sometimes an area that languages with a lot of useful and beloved features like type inference can struggle with. Does Roc compile quickly?
See, well, excellent direction right there. But before I answer that, just to finish that previous thread,
Yeah.
because it's fast and friendly, it's a great candidate for being used as a plugin language, because that's the sort of language where performance really matters. Because say you have an editor,
Sure.
or say you're writing a stored procedure database, like performance is really important, but you're opening this up to a very broad audience, and so something like say Rust, even though it's performant, might not be as applicable because it has all of this.
It has a bit of a learning curve. There's challenges there.
Right, right. So, but to answer your next question, why, of course, yes, Roc. That's one of the stated goals of Roc, is to be very fast at compiling. And one thing that once you start using it, you don't want to go back. I mean, it like once you realize how fast the compilation, the development loop can be, you say, what am I doing? Spending all of my life waiting for VMs to start up, and all these long compilation processes to complete. So yes, that is another. It's fast in terms of runtime performance and fast in terms of compile time performance, and that's like one of the main goals.
Yeah,
Um,
we're all about developer experience, so I'm glad to hear that attention has been paid to making the process of writing and iterating on your code um, accessible and low friction. Are you able to use Rock in your day job?
I'm not. No, we use Java here at work, and the reality is that Rock is not production ready at this point in a general scope. It could be used in some use cases, but for example, right now we're rewriting the compiler. It was written in Rust. We're rewriting it in Zig. There are lots of good reasons for that. We can talk about that if you want. But
I am a little curious. I feel like most languages, almost all, everything starts off written in some other language, and usually they switch to a bootstrapping compiler written in, the language itself. So if you're right, why are you moving to writing it in Zig rather than in Rock?
excellent question. And this is, we're touching on lots of great points about it. But this is another like explicitly stated tenet, I suppose, is that Rock will never be self-hosted. That is a stated goal. We are not going to do that.
Why
And
is
so
that a goal?
I'll explain. I'll explain. And so for many people, they view it as this sort of like rite of passage. That
Sure.
is, if your language is going to be any good, the compiler has to be written in that language so you can like prove that your language is actually worth its salt. It's like, this is good enough that you can write the language.
Mhm.
But what happens is sometimes the rewritten compiler is just worse, or the language gets worse because you're trying to support these features. So like, I'll give an
Sure.
example. Go, the compiler used to be written in C or C++, I think C. They rewrote it into Go. And I'm pretty sure that I heard some benchmarks about how it actually was slower after they rewrote it in Go, and because now you have to deal with a GC and runtime and all this. So Rock is a big focus is reliability and safety, and so there are some features that we will never put in Rock, like memory on safety, or all of these sorts of things that you might have more readily available in systems languages.
Hmm.
But some of those features can allow you to achieve the maximum possible performance. And so if we were to rewrite the compiler in Rock, we'd either end up with a slower compiler because we'd be barring ourselves from that absolute maximum level of performance, or we would be forced to introduce these features into Rock that would just make it a worse language, because we could never
Sure.
say Rock is completely memory safe. You don't have to worry about any of this stuff. Now we have to
Right.
say, well, if you put like an unsafe block or whatever, then you're going to run into these issues. So it just means that the language can be focused on what the language is meant to be really good at, and the compiler can be focused on what the compiler is meant to do. Because most people using this language are not going to be writing compilers. You absolutely can. I've
Sure.
written a compiler and an interpreter in it, and it works great. But it doesn't align very well with the goals of the project.
Yeah, I think that makes a lot of sense. Compilers are strange pieces of software, and most of the things most software that goes through a compiler does not resemble the operational characteristics of a compiler,
Right.
and so it proves what it proves to write a compiler in a language is limited. So
Right.
yeah, that makes sense to me. Um, your upcoming presentation at the Code Remake Summit is very much about Rock, or about how change is hard and Rock makes it easier. If you had like free reign in your day job to use Rock, like where would you introduce it? Like what part of your day-to-day enterprise software work would most benefit from the adoption of this tool?
Well, basically all of it, so any of it, honestly, anything on the back end side. Now, granted, I am not generally, now I'm happy to talk about this more in detail, why we're rewriting the compiler, but I'm generally not, I'm of the camp that usually rewriting things totally is a bad idea. So I'm not saying that we're going to go rewrite, 500,000 lines of Java into Roc tomorrow and that's all going to be a win. I'm not
for sure.
That. But the place that I would want to use it is if we were launching a new product, say with a new web server or something like that. That would be the first obvious use case. Because really, there are lots of issues that I deal with day to day that I have to think about that introduce bugs down the line or make the development process slower or just cause me stress that could be solved by
what are some of those issues?
Well, let's just look null, for example. Null pointer.
Yeah, null.
That's that's a big one. That's
absolutely.
Security concerns. That's a very interesting one. Error handling, like another Java one. Let's say with error handling in Java, a million kinds of exceptions can be thrown by anything at any time, and you can never really keep track of them. And maybe you can use some checked exceptions to keep track.
Those are such a pain in the ass. I hate checked exceptions.
Exactly, they're a huge pain, and it doesn't really tell you much because it's like, okay, this function might throw this one kind of exception, but it probably throws another 75 kinds in various circumstances. So that's an example where Roc's error handling is the best out of any language I've seen. And I've looked at a lot of languages. It's the best out of any I've seen because it's somehow the most informative and safe while also being like one of the most convenient to use. And so I can go into more detail about how this works. But in my editor, I can hover over a function that might return an error, and I'll see this function can return these 7 different kinds of errors. Each of those errors is going to contain some descriptive kind of payload with any information I need pertaining to that error. And the great thing is I don't have to create any new types, and I don't have to update any type signatures or anything to do this. It's all just automatically propagated through the compiler. So you can see, I can look at a function and see, these are exactly the error cases I need to think about. Nothing more, nothing less. That's it. And yet you're just writing
I like that. I like the sound of that. Does it how does this work? We get do all functions return like a monad, like we have an optional or an either kind of thing, and you have to check the type. Is this the data I'm expecting, or is it one of these 7 errors, and then unwrap or map on top of that? Is that I've seen plenty of functional languages do I've seen the argument that in like Java, like the throws exception that's actually part of the return type, essentially. Like this function returns its real value or this exception. Is that the paradigm here?
Yeah, that's a general idea. So I would say, so Roc uses the idea of errors as values. So in Java, your function, you see, oh, this function returns an integer. That's the return type, and then there could be an exception. And again, you could think of that as being part of the return type. But basically, it's like there's a separate stream where all of the errors flow out of. Yeah. In a language like Roc, you'll just have one stream. So there's no concept of exceptions or anything like that you have to think about as a developer. It's just functions that return values. So I look at a function that returns a value, and if that function could fail, that it will return a result type. So it'll be called result, and it'll have as the first argument the type of the success value, and the second argument will be the type of the error value. So if I have, say, divide is my function, it could be a result that returns either an integer or a division by 0 error. Right. Now, but there are several things and that part right there, that's sort of table stakes. A bunch of languages do this or things like this, so there's nothing special going on there. But first, one thing I'll say is that mapping and unwrapping and dealing with all of that can be kind of a pain and a pain point in other languages. It's much less of a pain in Roc because there are convenient utilities built in for handling these errors and letting them bubble up. So if I have a function that returns one of these errors, I can just stick a question mark on the end of the name, and then that is sort of like saying, I'm assuming that this is going to return the success value. If it fails, then just throw that error up to the top level, let the top level of this scope handle that.
And by throw the error up, you mean return the error from the current function?
Yes. So it's not actually throwing. It's a bad choice of word, but it lets it bubble up to the top scope. And so Rust does this, for example. So again, that's not unique there. That's not the special sauce, but it's good. It's better than most functional languages that use this sort of thing. They sort of make it more difficult to do bubbling. And then the point there also is that gets you a nice feature of exceptions, which is that exceptions let you just sort of bail out and say, just throw it away, let someone else handle it. So you can still do the same thing with Roc error handling. Now,
that's nice. Most of the time, what you've got in any application, regardless of language, you've got like, this is the spot where I handle errors, and any error, where I return information to the user or put it in the response or whatever, and anything below that should just bubble up to that point. So, most of the layers, their error handling is let someone else deal with it. So let someone else deal with it should be something that's very easy to express in the language's error handling semantics, and is why checked exceptions are so damn annoying. Exactly. Anyway, I'm sure do we have a recipe for Java to put Lombok sneaky throws on everything? We could make that recipe if we don't.
I think we have a general one to add annotations to things. If you just add wildcards everywhere, then we should be there.
Yeah. Yeah. So just to take that and combine it with something that finds checked exceptions, and then there, boom, you've got your no more checked exceptions in Java recipe. So yeah, what is here we deal a lot in abstract syntax trees, or lossless semantic trees, as we like to call them. What's the compiler internal representation like, and how when are you going to be creating an open rewrite parser for it?
Well, I would say it's pretty standard AST sort of stuff, and I don't know. I have thought about that. That it would be nice to have Roc integrated with open rewrite. So maybe soon, we'll see. But I didn't tell you. I didn't tell you yet.
Rewrite.
Oh, go ahead.
I was just going to say, someone who's interested in open rewrite and already knows some compiler internals sounds extremely qualified to create such a parser.
I guess so. I guess maybe that'll be. I'll add that to the project pile.
Excellent.
And we do have the hack track in Miami. So if you want to nerd snipe one of us, then definitely.
That's true.
There you go. There you go.
Help you bootstrap a parser for it.
Yeah, sweet. I haven't yet told you the secret sauce of why the error handling is so good. Would you like
there was more. Sorry, yeah. What's the secret sauce?
Yeah, everything up until that point is sort of like table stakes. In other languages. But what you don't get in other languages is the ability to hover over a function that fails and see exactly what kind of errors it could return without having to create some new error type. So a common pattern is to return an enum of errors. In Roc, that's called a tag union, and they're sort of a little bit more enriched than an enum in like Java, because each tag can have a different payload with different kinds of data in there. In other languages like Rust, again, you can do this. You can create a type, say, here's my, let's say IO error or something like that, and it has my 7 different errors that can happen. But you're going to have each of your functions return that IO error type, even if that one of those lower level functions only could return one possible error of those 7 or something like that. In Roc, we have structural tag unions, which basically just means that you can have a tag union that you don't have to explicitly declare somewhere, like an enum that you don't ever define. It's like an anonymous enum.
Okay, so the compiler can infer the set of
right.
Okay, yeah.
So in your function, you just create a new error right there. You just summon it, and then the compiler will infer the error type contains this error, and it'll show you exactly the errors that are actually present in the body of your function and the functions that you're calling. So then without any manual bookkeeping, you get this exact record of what errors each function is returning. So it's as if you had checked exceptions for every error, except you never had to deal with writing, adding
overhead,
or anything like that anywhere. It just was done automatically for you. Oh. So that's really the secret sauce, is the structural tag unions that automatically merge as you call functions, and that's much less common there.
I'm glad to hear about the rich IDE support, as back when I was in college and graduating, I was very interested in what different programming languages had to offer. I was very drawn to both the expressive power of a Lisp with all of the macros you can define, as well as to the type safety and also expressive power, but in a different way of, functional languages like OCaml and Haskell and all of that. And I was often a bit turned off from those when like the IDE support would be like, well, here's how I like to customize my Emacs, or here's a plugin for Eclipse that like half works. And I'd be like, well, like the expressive features in the language are cool, but if I can't like see the methods that are available off of this type right there in front of me, the user experience is just simply not worth whatever else the language has to offer. So, what editor or editors support Roc in this with all of the detail and the support you're describing?
Any editor that supports the language server protocol, which is every
Lots
editor,
of them at this point,
basically.
Yeah.
So Roc, we bundle a language server with it right now. So if you just download a release, you'll get the editor or the compiler and the language server right there. It's very easy to set up, straightforward. So in this case, like with the error handling, there's not even really any special sort of tooling that is involved to make that happen. You just need to be able to hover on a type and hover on a definition and see what the type is. And the language server, that's a very standard language server thing. So it works right out of the box. And yeah, I think tooling is an interesting thing to bring up, because that is often that is something that you have to think about, because there are a lot of great languages where the tooling kind of sucks. And that even if the language is great, if the tooling is terrible, why are you going to use this? And so that's something that we're very aware of working on Roc. And so it's important to invest in the tooling from the beginning and make sure that it's nice. And there are also other ways that you can sort of inject tooling without needing a company like IntelliJ building this, beautiful IDE language. So in the new compiler, there are plans to have a debugger built into the CLI, for example. So you'll be able to set a breakpoint in code, run the code with the CLI, and then immediately jump into a debugger when the breakpoint is hit, which is not something I'm aware of in many other compiled languages. And so that's a way that we can give you this richer experience with the tooling that you don't get in a lot of other sort of niche languages, without also having to build a whole IDE at the same time.
Yeah. So what's the debugging experience like right now? Is that just like part of the language server protocol, so the existing ones are able to debug a running process without, like, can you debug Roc in an IDE and step through line by line?
No, you can't. I'm not aware of anyone doing anything like that. You could hook up like GDB or something to it. I'm not very familiar. I haven't used that much myself, so that's not a great experience. Also, then you're going to run into weirdness if the compiler chose to like inline something or something like that. Then, it's
mapping that back to the appropriate line in the source code is non-trivial.
Right. Yeah. So we definitely want there to be a feature where you can in an editor step through your program, but that's not the state now.
I see.
Yeah, but there is a lot of opportunity there to, I think, remove, language decisions can sometimes remove the need for some tooling. Like once your CLI becomes good enough, or the design of your language is nice enough, like some problems just go away that you don't have to worry about them. So, yeah, but tooling is important, and that's definitely a focus.
Yeah, I don't know that anything will ever fully replace a debugger, since no matter how elegant and comprehensive your like type system is, or your representation of it is, at some point your code might interface with the system that isn't under your control, and you might map out what you think its APIs or responses are, but you have to test your assumption that that's the case. And I often do my programming in the debugger with like a breakpoint hit, so I can call the relevant APIs right there, from the running virtual machine with all the relevant types loaded up, and see what things actually return, so as to test my assumptions about their behavior in real time. And particularly if you're working with like a really large or complex data structure where you might not have in mind what values to expect, even if you have things thoroughly annotated with deep types. It brings to mind the stories, the lore I've heard from the Smalltalk developers, which had a very message passing based way of calling functions, where they would write code in their IDE as it was running, and and be able to iterate very directly with, in conversation with their program. And I've always been interested in that idea, as even in languages that don't have that paradigm, that's often how I just happen to go about things.
Yeah, and I will say that I think sometimes people who are using languages, that are not as well established, they like to say, "Oh, you don't need a debugger." Like, debuggers that's just a skill issue, which is stupid. Debuggers are amazing. It's like magic. Why would you not want a debugger? And that's definitely
Totally.
we're in Roc. And I'll say on the example, I do the same thing about writing code with a breakpoint hit. Having access to that whole environment is so valuable, and so that's another thing that we're planning on supporting in the new compiler, where you will be able to hit a breakpoint, and then hopefully, this is not implemented, so no promises, but I think it's a credible threat here. Hopefully,
I'm gonna start talking about like features as credible threats. I like that.
Right. Then you'll be able to do hot reloading of the source file with it while keeping much of that context loaded. So the hope is that we could still provide a lot of that experience in sort of even more of an agnostic way, because you're not then coupled to this particular IDE that you have to use. It's like just if you have the CLI, you have this cool thing right there, whatever editor you use.
Right. What is how does I've worked on a lot of build tools and developer tools. What's the dependency situation like? Is this like a Go paradigm where a dependency is source code that you copy in and compile within the context of your own project? Are there binary dependencies, like a jar? Like, how does one compose together Roc projects that live in different places?
There are not binary dependencies at this time, at least. I don't know if there are plans to support them, but the way it works right now is that someone can publish a release of their package. The CLI will do that. You run roc bundle, that releases your package, and it generates a hash based on the contents of your package as well. And so then you upload that artifact, say GitHub releases, then someone copies the URL to that, pastes it into your project, and then the CLI will install that for you automatically.
And inside that package is source code.
Yes, correct. And then there are a lot of security considerations that went into that design, so that, for example, if someone, because the hash is built into the URL that you're putting in your project, if, say, the URL expired, the domain expired that the package was hosted at, and someone put a bad version of the package up instead, your code will fail to compile because it'll validate the hash when it tries downloading the package and see that the URL does not match the code.
Yeah. All right, I like that. That's good. That's a good feature.
And if we want to talk about security here, Roc also provides a lot of guarantees when it comes to security that you just can't get in other languages. So that could be an interesting direction, but it's up to you where you go.
What? Yeah. Tell me more. Tell me more about security.
Well, I'd love to. Thanks for asking. So, another thing about Roc is that it manages side effects, and so it doesn't do this in an annoying way like some other languages where it becomes really hard to just print to the screen or read from a file system. But it keeps track of them, so you can say this function has to be pure, as in it's like just a calculation, or this function is effectful, it can read from the outside world, or things like that. And then the second part is that within Roc, all of the effects that you use, such as reading from the file system or making an HTTP request or something like that, are passed in from the platform, which is basically the substrate that your application runs on, that can vary based on the context you're running your application in. So this means that if I'm writing a Roc package to do some common utility, that package will be completely pure, and it will explicitly ask for the effects that it needs to accomplish things. So say you write a logging package. You have all your things about log levels and formatting and all that. That's totally pure. And then you say, I need you to give me an HTTP request effect to run this. Then you, the application author, pull in the logging package and hand it your HTTP request method. That's the only effect it can do. It can't read the file system. It can't cache data. It can't phone home. It can't do anything. It can only make an HTTP request. So that's cool. But it gets even better because you're explicitly passing this in. So you can say, this logging package should only ever make requests to Bugsnag or CloudWatch or I don't know, whatever your logging service is. So then you can make a custom version of that HTTP request method where you say, you validate that the path of the URL path is that one, and then hand it off. And now you know that is the only thing the package can ever do. And this is something you just cannot get in other languages because you don't have this sort of compiler level management of effects.
Sounds a whole lot better than building in LDAP support into your logging framework.
Right, exactly.
Yeah, I like the sound of that. That sounds good. That sounds like a good thing. Yeah. Oh, all right. Yeah, I like that. I like that a lot. Is there like a notion of like aspect-oriented programming? Oh, I remember the other question I was going to ask. But like, if you're like, okay, I have all of these peer functions, I would like to wrap them all in a logging statement of like this function was called. Is there like a meta programming layer that enables that kind of thing?
There's not, and that's another intentional design decision, And this is Roc leans a lot in towards the side of explicitness, which I have come to love. In that, sometimes you're going to have to do things in a little bit more, like you're going to have to actually write the code instead of an annotation or something like that. But it means that when you have to debug the code's right there, and you can look at it and see what's going on. So that's like we use Spring at work. And Spring's wonderful. We're very productive. It's very cool.
It can definitely be very magical with its annotations.
Right.
Yeah.
It's extremely magical, and that's great when it works. And then when it breaks, it's an absolute nightmare. And I want to pull my hair out. And this is something this is a regular occurrence on my job. This isn't hyper.
Oh, I know. I believe you.
Yeah. So that's sort of the kind of a core value is that explicitness, and I think also. Many frameworks or languages try to do a lot of this stuff for you, and that's like an expectation that we have, I think, with a lot of languages. Mm-hmm. But it may be that we've never tried just doing it manually. Sure. And sometimes when you try doing it manually, you realize
it's not actually that bad.
Right, this is hardly any code. Like, what's the big fuss here? So
people talk about like dependency injection frameworks and stuff. Like, oh, that sounds hard, and using some of them like Dagger can be kind of complicated or error prone. But if you actually just write your code in the style that supports, it's not actually that intricate or complicated or difficult. It's just all the fields on your class appear in the constructor. Ooh, you have dependency injection now.
Right. Yeah, totally.
Yeah. So the other thing I was curious to ask about was multi-threading, parallelism, concurrency. Is this language single-threaded?
So that's excellent question. Glad you asked. And this is again where platforms come in. So I haven't really explained what platforms are. Basically, your application is a piece of Roc code, and that Roc code is a little bit agnostic as to the environment it's running on and what sort of domain it exists in. So you then write a platform that provides the footing for the Roc application based on the specific domain you're working in. So you could write a web server platform, you could write a CLI platform, you could write a game engine platform. There's a platform that compiles to the WASM-4 virtual console, whatever your domain is.
Are these platforms written in Roc, or are they in Zig or anything?
Great question. So the platforms in lots of different domains, and those are going to be written in any sort of systems language, and actually any language you want that speaks CFFI or the CABI. So Zig is a popular choice. Rust is also popular, but C, Java, Go, Swift, whatever you want, whatever your domain is. Okay. So then the platform, sort of defines this like infrastructure that can be shared. So like we have a web server platform, for example, that's written in Rust and uses, I think the library is called Hyper, which is like a popular Rust web server library. So that handles all of the, web server stuff that's important there. And then you can just glue the Roc on it to do all of your business logic handling each request. So when it comes to concurrency, this is dependent on the use case. This is depending on how the platform decides concurrency should be handled. So the model is that Roc does not have concurrency stuff built into it directly, but the platform will choose what makes the most sense and then control Roc in that manner.
Interesting. So it seems to me that Roc is really taking this idea of being a language for embedding or for domain-specific languages very seriously, and that like the primary operating mode for production software would be embedded in some other system that was providing some of the baseline functionality. That's
Totally, yeah.
interesting. That makes sense.
It's a
If the
very,
goal was a DSL almost.
right, yeah. It's a very core assumption, but the interesting thing there also is that for a lot of use, you don't think about that, or it doesn't feel like that at all when you're using it. You just, say, oh, I have the basic CLI platform loaded up, and I just write my CLI. So like you're not thinking about like, oh, this is a DSL or it's embedded. It's like that's just what you happen to be using in that context.
Right. Yeah. All right. Well, that makes sense. I have async await in some languages is a little bit of a something I don't love. This some of this infrastructure to support coroutines or similar ideas of concurrency ends up like you use it once and it like infects the whole rest of your code base, since async methods can only call other async methods, since they require special compiler support in the languages that have those. So just kind of saying not my problem is is valid. It's better to have no solution for it than not no solution, but to abdicate responsibility for the solution rather than providing a bad one.
Right. Yeah. And this is a great example. This is, again, not something that's been implemented, but something that absolutely could be implemented. Is that you could have a platform that would do asynchronous I/O and all of that without having to expose that in Roc at all. It would just do all of the I/O asynchronously, and you just
right. Whenever your Roc program requested that functionality that was going to be platform provided, if it wasn't ready yet, the platform would just block and not return that value, return the value and control flow back to the Roc program until the data being sourced from wherever asynchronously was ready.
Right.
Okay. All right. That's cool. So yeah, how are you going to get Roc into your day job, right? Like you've talked about how good it is to embed, and you talked about like maybe if we had a greenfield project, but you don't necessarily always have a greenfield project. Is there some place, whether it's in the developer tooling or the build plugins or the test framework or something where this would where it would make sense to add this into an existing project that you actually have in your day-to-day enterprise development?
Yeah. Well, one example, is it's also good for scripting, and that's sort of a goal of the language is to be finally like a safe, reliable, statically typed language that's also good for writing scripts.
I like the sound of that. I hate Python scripts.
Right. So, I find myself writing a lot of bash scripts in CI, for example, and like it's nice for simple things where it's like every runner has bash on it, of course. So like whatever,
Totally.
it's fine, straightforward. But as soon as you start doing something with like a list or like what, it's like, oh man, give me something better here. I need some help. So
absolutely,
that's an excellent use case, and that's a use case that Richard Feldman, the creator, has sort of had in mind from the beginning, and that's sort of guided some of the design decisions to make sure that it can be convenient to write. So that's a good idea. I could try introducing some of those. It could also, yeah. I mean, I think if you I will say that I'm not a fan of like total rewrites, but maybe smaller
yeah,
rewrites.
me either.
So for example, there's a one product that we will likely pull out into its own application at some point. So that even though that wouldn't be greenfield, that would be make it a much smaller sort of isolated world that could be more reasonable to start introducing things into. But the reality of it is that the language is still being developed, and we're in the process of writing a new compiler, and so
sure.
I'm not going to stake my everything on this language where before at this point. I mean, obviously I'm very committed and excited about it, and I'm talking to you about it, and I want it to succeed, and I'm working to help it succeed, but I want the new compiler to be operational before really depending on it heavily.
Cool. Yeah, that makes sense to me.
And another thing to call out there is that, like, I think a lot of languages end up being very like toy sort of things, or like curious projects, things like that, and it's that where it's like there's this inevitable, like you're making the gap even larger for how you'd make it into production. But everyone working on Roc is working on this because we want it to be easier to build reliable software, fast, reliable software, with ease. And so it, like, getting it used in production is a very high priority, and that is the goal. It's not like an afterthought. That is the reason we're doing this. And there already are people using it in production. There are some I think there's an agency actually in the Netherlands that's using it, and they've I guess you already found that. Yeah. So
yeah, they're right around the corner from where I used to work. It's they're here in Nijmegen. It's I think the name is Tweede Golf. So they're using they're one of the sponsors of Roc, and
very nice.
In my hometown.
Yeah. So anyway, so that's the goal. That's where we're moving towards.
Totally. So you've told us a lot of kind of cool things about this programming language and its past, present, and future. Do we need to come to your session at Code Remix, or have you shown us everything there is to see already?
Absolutely, you need to come to my session. I mean, I have shown you just very little of what I'm going to be talking about in my session. Honestly, I haven't said anything about why changing software is hard, or how it might be that a language can make that easier. And I've given you some nuggets that will be mentioned in the talk, but there's plenty more. So don't worry, I'm certainly not spoiling.
And I imagine attendees could expect, live demos and live coding of some of this stuff.
I don't know about that. I'm not generally a live coding fan. I at the talk I gave last year, I had some live coding built into it, and then I did like a run through with some people in the Roc community, and they were like, "Yeah, you should just make all of that into slides," and then way better. So that's been kind of I guess a shaping experience for me. I was like, I wasn't really gaining much from doing the live coding, and now everything's predictable. Everyone can read it easily. There's no awkward like, let me try to get into my editor. Can you see that?
It can improve the pacing, not to do it live. Yeah.
So probably not live coding, but there's plenty. I mean, Richard, like 6 months or so ago, he did a live coding video on Funk Prog Sweden. It's a YouTube channel. They have a lot of functional programming stuff, but that's a great video because it sort of highlights a lot of the feeling you get while you're programming, where you get this really fast iteration and you can write things in a very it feels like you're writing Python. You're not writing any type annotations down or anything like that, and yet the compiler tells you about everything you do wrong in a really helpful way to keep you going. So that's a good recommendation if you want to see some live coding. But I'm not doing that.
All right, that sounds good. Yeah, well, I look forward to seeing a little bit more of what you're talking about, even if you're not live coding it, but just showing more code samples, more examples of like what the IDE and developer experience is like. And to hear about how you think this will fit into modern enterprise software development going forward.
Sweet, yeah, I look forward to it.
All right, Alice. Do you have any final questions for Mr. Isaac, Tim?
Look, mostly wondering, you can't yet use it at work. So what are the interesting things that you have been doing with it? Is it like Advent of Code? Is it like Battlesnake? Is it something else still that you think is a good fit here?
So yes, Advent of Code, that's true. But a variety of other things, some web servers here and there. But one interesting thing I've built in it, which is actually what the talk I gave last year was about, is a template language sort of inspired by Jinja, I guess, in Roc, for like HTML templating or really any sort of content you like. But the motivation behind that was I use FreeMarker template at work. It's, in a Java ecosystem one. And I like a lot of things about it, and that it feels very productive. I can, ship software very quickly using it. But it absolutely grinds my gears that it does not give me any feedback until I'm running my software. And I have no validation. I have no guarantees that I've caught everything. Right. So it could be that I don't realize that some field could be optional or null or something like that. And I didn't test that. And then it makes it into production. And then you find out, now that it's just defaulting in some weird way, or there's some error because of this thing going on. And so that that irks me. So I want to fix that. And so I built a template language that does fix that. The idea is that it gives you the sort of developer experience you'd get from a dynamic template language like FreeMarker or Jinja or something like that, in that the way your template is written is like exactly the same pretty much. And yet you get all of this compile time validation. So you compile a template. It's not like interpreting it or something like that. But you compile it, and the compiler will tell you, hey, you use this field in the template, but you're not passing that field in to the template when you try to use it in your code base. And so then it's like, voila, that saved me so much time, because those errors show up all the time in FreeMarker, or you're constantly using typos or all this sort of stuff. And so I think that is kind of a nice illustration of one of the things that I like so much about language, is you're getting all of this safety while somehow still keeping all of this convenience that you get from these other languages. Like, how am I getting both of these at the same time?
And I could really see that, like, if for a language that's well suited for embedding, that is something that you could then plug in somewhere and maybe even work into a side project at work. So.
Yeah, totally.
Cheers.
All right. Well, hey, thanks so much for coming on, Isaac. I'm looking forward to seeing you and hopefully all of our viewers in person in Miami in a few short weeks.
Absolutely.
Thanks
for that. Yeah, thanks for coming. And then I hope to see you all next week. Cheers.
Cheers. Thanks, everyone.
See ya.
Join us in Miami for Code Remix Summit. Attend hands-on sessions with some of the best industry experts. Looking for immediate ROI by attending? Bring a relevant business case and work directly on solutions affecting your organization in the hack track. Bring your problem, bring your laptop, and walk away with work done for your boss. Register today for Code Remix Summit.